Alright, so this is factoring by splitting the middle term. Okay, so here's just some things to remember. Remember that we were multiplying binomials together, and we were using the box to do that, right? And then whenever we would do that, we'd end up with three terms, as long as we didn't have the difference of squares, right? And so you can see this isn't the difference of squares, so we should end up with a term here. And we remember that when we use the box, all we have to do is just multiply in, right? So remember what I said was these two that I just filled in always add together, right, on the diagonals, and they give you that middle term. So I know that this middle term should be 7x, okay? But today we're going to be taking one of these and trying to go here. So basically we're doing what we've been doing backwards, okay? So instead of going this way using this and coming out with my answer here, I'm going to start here, use my box, and come out with it backwards. And the way I have to do that is by splitting the middle term, okay? Because this is what's kind of cool about math, is that these two numbers, there's only two sets of numbers that will give us these right here. So, I know that sounds kind of weird. This is just a real quick example to show you what I mean by this. So I'm going to pretend like I don't see that over there, and I don't know what the answer is. And I'm going to try and factor this trinomial, okay? And the way I'm going to do that is, again, I'm going to start with my box. And here, what I did was, the reason I put these in red is because these are the ones that you want to look at. Because I know when I use my box, this one is always my first box, right? There's nothing else that can make that term. So I know just by looking at this, if I start my box, I know that this has to be x squared. And I know that my last box is always my last number, so I know that this has to be 12. And again, my box is made by multiplying, right? So whatever's on the outside is being multiplied inside. So if this is x squared, what times what gives me x squared? Well, I know it's x and x, okay? But the hard part is figuring out this 12, because there's lots of numbers that multiply up to 12, right? I could do 1 times 12, I could do 2 times 6, I could do 3 times 4. All of these work, but I don't know what pair it is. And I could spend a lot of time plugging in each one of those out here to try and get these numbers here. But what's nice is that this number kind of gives me a hint. And the way that I'm going to do that is I'm going to use what we call the diamond method. And what I'm going to do is I'm going to take my last number and I'm going to put it down on the bottom. And I'm going to take this middle number, since I am given this in my problem, and I'm going to put it up here. And what I'm going to say is I want two numbers here. And the two numbers must multiply to give me this bottom number here, but they must add up to this number here. So again, I'm looking for two numbers that multiply to 12, but add up to 7. And you always want to write your signs of these numbers, because the sign is very, very important. Okay? So multiply to 12, but add up to 7. Well, if I look at my factors of 12, I'm never going to get to 7 here. And I can't get to 7 here, because this is 8. But if I add 3 and 4 together, and if I multiply them together, I get 12. If I add them together, I get 7. So I know that this number must be 3 and this number must be 4. And again, it doesn't matter which side you write these on. This is just a form so that we know what to put here. And again, remember I told you when you were doing this originally, it doesn't matter which factors you write where, as long as you keep them separate. So I'm going to do the opposite. I'm going to put 3 here and 4 here, because that's where I find these numbers. And I always know that these are my x terms, right? Not only that, I know that I'm multiplying by x, so this box must have an x, right? But these are both positives. So if I add these together, I get my 7. Now I can find these two numbers out here just by using logic. So I know that x times some number equals 4x. Or I could think of it as 4x divided by x gives me, and it's going to be a positive 4. Okay? Down here I can do the same thing. 4 times what gives me 12? Well, that's 3. And just to make sure I can double check everything, 3 times x gives me 3x, that's right. And I already did the 4x, but I can do x. Oh, no, that's it. That's everything. So I can see that my answer is right here. X plus 4 and x plus 3. And again, you always want to write it like this, okay? So that was just a real quick example. I'm going to try and do it a little bit faster now with a few more problems. So we're going to start up here. Example number 1. Now I don't have the answer for you, so now we're going to have to do a little bit of work. So I'm being asked to factor this, so again I'm going to start with my box. And again, I don't know what the outside numbers are. All I know is that my first box should be x squared, and my last box should be 2. Well again, if this is x squared, I know that I'm multiplying x times x to fill in that box. But I don't know these. I don't know the outsides here, and I don't know the insides here. So I'm going to use my diamond. And my diamond, again, I use this last number is my bottom number, and this top number is this middle number here. So what multiplies up to be positive 2, but adds up to be negative 3? And this is always going to be a real hint. If I multiply to get a positive, but I add to get a negative, well then I know I must have 2 negatives, right? Because a negative times a negative equals a positive, but when I add them together, I'm going to get a negative. And there's only one set of factors for 2, and that's 2 and 1. These add up to negative 3, these multiply up to that. And again, it doesn't matter which place I put these. I can put the negative 2 here or here. I can put this negative 1 here, here. I just have to choose which one I want to do. So I'm going to put the negative 2 here, and again, I know that this should have an x in it because it always makes my middle term, right? And that one should be a negative 1x. Now that I have the inside filled, I can finish my outside. So again, x times what gives me negative 1x? Well, that's just negative 1. And negative 1 times what gives me positive 2? Well, that's a negative 2. So my final answer is going to be x minus 1, x minus 2. Okay? And again, thing I like about this is that your answer, even though it's out here on the outside, it looks kind of funny. When you write your answer in, you can easily check your work to make sure that it makes sense, because you have what you started with up here, and you can easily check that with your answer with the box. Negative 2, negative 1, that gives me negative 3. I know that this multiplies up to that. So within just those few steps, I can do my check. Okay. Number 2, I have here, so again I'm going to start with my box. And I know that the first box is my first term. The last box, this bottom box down here, is my last term. I don't know the other ones, I'm sorry, but I do know that this is x and x, right? I don't know my other ones, but again, if I use my diamond here, I can figure it out. So negative 14 multiplies up to negative 14, adds up to negative 5. Well, again, I know this is negative and this is negative. And if they multiply up to a negative, well then that means I should have a positive and a negative, right? So when I add them together, I'm not really adding, I'm kind of subtracting them. But I get a negative number. So I also know that this negative number must be larger than this one. In fact, I know it should be 5 digits larger than the other one. So let's think about this. Factors of 14, I have 14 and 1. Those aren't 5 digits apart from each other. I have 2 and 7. And 2 and 7 are 5 digits apart. So let's think about this. This one should be negative 7, and this one should be positive 2. Okay? If you get stuck on finding which 2 digits, what I would do is just like I did on the first problem, I would start writing them out. 1 and 14, 2 and 5, 3 and, nope, there is no 3. How about 4? There is no 4, 5, no, 6, no, 7, and, oops, I did that backwards. It's 2 and 7. So those are it, right? No wonder I was having trouble finding the other one. Excuse me. So 2 and 7, again, doesn't matter which place I put them. This time I'll put the negative 7 down here. And again, I always make sure that I put the x because I know these middle terms always make the middle one. That's why I'm splitting that term into these two. And I know that this should be positive 2 and this should be negative 7. So again, writing my final answer, x plus 2, x minus 7. All right. Example number 3. Same process. We should be getting a little bit faster at this. I know that this is going to be x squared. I know this is going to be negative 7. And this should be an x. And this should be an x. What I don't know is these two. So again, I use my diamond, negative 7, positive 6. And again, I have a negative up here and a positive up here. So I know that this should be negative and this should be negative because, oops, I take that back. I should have a negative and a positive, right? Because they multiply up to a negative, but they add up to a positive. So this is just the opposite case of this one. Here we got a negative up here, here we get a positive up here. But I still know that one should be positive and one should be negative, except this time my positive number is going to be larger than my negative number. And again, since we're dealing with 7, there's only one set of factors for 7, and that's 7 and 1. So I know that this should be 7 and this should be 1. If I add those together, I get positive 6. If I multiply them, I get negative 7. Okay? So I'm going to put the positive 7 down here. And again, that's positive 7x. That's not a 17. And this is a negative 1x. Again, I look and I see that x times negative 1 will give me negative 1x. And here I see that this should be a positive 7, because positive 7 times negative 1 will give me negative 7. So I see that my answer is on the outside. And I can write my answer. Okay? So I know this looks like a bit long process for each problem, but if you use logic, here's a couple hints that you can use. Remember, when you start your diamond, if the top number is negative and the bottom number is positive, like we had up here, then we know that our two numbers, these two numbers, must be negatives, okay? And the top number is going to be adding those two negatives together, okay? We also know that if I have a negative on the bottom and a negative on the top, like I did here in example 2, I must have a positive and a negative, okay? But again, we also know that the negative number must be the larger number because when they add them together, you get a negative, okay? Positive and a positive, like we did in our last problem. Oops, sorry, no we didn't. We didn't have a positive and a positive. But if we do have a positive and a positive, that's kind of like the first problem we did on the other board. But if we do have a positive and a positive, well then I know that these two numbers must be positive, okay? So these are things you can do in your head real quick to start filling out your diamond. Makes things a little bit quicker. And remember to have your question ready to go for next class period. Other than that, I hope this has been helpful, and I hope we can now factor quadratics a lot faster, and you shouldn't run into any trouble.